Again, good morning and welcome to Astronomy 100. There is already a change that you guys, I don't know if I made the announcement for it or not yet, but probably I'll send you a more formal, thank you, Daniel, send you more announcement regarding to it, and that is the office, basically. I will be on campus from now on at least, I'm hoping once a week. If I cannot make it, I will let you know. But if we're going to meet on campus, you really have to communicate with me ahead of time, meaning you have to send me an email telling me exactly when you're coming so that I can put you for the schedule on that time. And because we have to observe all of the safety and health guidelines, but I will be on campus, most likely Wednesdays. I know this week I was on Tuesday on campus, but that's the plan, is to be on Wednesday on campus. And hopefully if you guys want to meet, have any questions and things like that, I can answer them. The initial plan is for a minimum of 2 hours, potentially far more than that, because of the, I will be probably most of the morning in there until like 2 o'clock or 3 o'clock before I leave. However, you really have to communicate ahead of time for me to meet, so that first of all, I stick in the office and then we can meet. The office in the building 2700, it's I think room 2777-1, meaning that I share the office with another faculty. It's the second floor in the 2700. So when you go to the faculty buildings, I think there is the, immediately after you come from the stairs, from the main entrance, from the entrance from the parking lot. When you go upstairs, it's the first one, the first side of the faculty offices. And when you go in, you have to go around the corner and you will see my office in there. So that's one thing. The other thing also that I sent an announcement for today, and hopefully you guys have had a chance to look at it, is there was an assignment already, a homework assignment for 2 problems. And I know one of your classmates, not from this section though, it's from another section, sent a request because the question 13 was a little bit not clear. So what I did today, I recorded a video. Basically, I demoed the, I tried to draw the tropical regions and also the Arctic region, and you have the equator and all of that. And I simulated the current position of the Earth going around the sun with the tilt of the axis of the Earth with respect to the ecliptic by about 23 degrees. What happened to the seasons, especially the Arctic zones and also the tropical zones, what happened to them when the tilt is almost twice as much or more than twice, because 23 degrees and the question was about 50 degrees. So, and my hope is that you guys first of all do the demo. Do not rely on mine. I sent you the link for the video so that you can look at what I did. But see what you're going to find out. What happened to the seasons there? Demo it and see what happened and try to answer it. If you are more of a geometry inclined, you can actually use a geometry, but the geometry in 3D is not easy to do, because most of the time we have stuff on the flat screen or flat surface, and that is a 2-dimensional shape that we deal with. So what we have is a projection of the Earth on a flat surface, and that's hard to imagine. It's much easier actually to demo and then go around it and see what happened to the seasons when the axis of the Earth. This is important. That question is important because it has implications onto the seasons and the potential for life, and because most of the exoplanets, the planets that are outside of the solar system that we are discovering, are very, very close from their host stars. And they have to, because at this point we really don't have powerful techniques to find planets further away from their stars. The easiest way for us right now is the planet is close enough from its star, host star. So when it goes in front of it, it basically cuts a little bit of the light that comes to us, and we will see the effect because we cannot really see exoplanets. They are too dim for us, and the stars next to them are so bright that we cannot see them. So the best way to do it at this point is to actually take the light and analyze the light and see when the light dims, and that's how we find out those exoplanets. But most of these exoplanets are close enough from their stars, and they are tightly locked with their host star, meaning that they're facing the star all the time in one face, just like the moon. When you go outside and look at the moon, you always see one face of it because it's tightly locked with the gravity with the Earth, so that it stays facing the Earth all the time at the same face. Same thing with these planets. So the seasons there are different than what we, there are no seasons basically, unless you happen to, for a species or a life to live right on the edge between the dark region and the bright region of those planets. So the question is interesting, and I'm hoping that you guys will enjoy it and analyze it. So that's part of the homework. So that's I sent earlier today. So hopefully you guys will look at that homework assignment, and the answer is a lot simpler than what I'm describing right now, but I'm hoping that you guys also can expand. Okay, so this is in terms of the announcements that I have in mind. So hopefully you guys have looked at that announcement, and the first one, the fact that I will be on campus, and watch for another announcement concerning that, because I would want to put it ready for you guys so that you can be on campus. Next week is, I don't know if we don't have a class on Monday, so we don't have to worry about it, but we will meet in the regular time, which is on Tuesday. So the regular time when we have a live session, unless of course we have something else happening. So let me share with you the screen to tell you exactly what we're covering this week. I know you have had a chance to go through it, but let me go through it quickly, and hopefully if you have any questions, I will answer it and discuss what we have in here. Let me see first of all, is this unit 8, 9? Okay, I'm missing, okay, I'll find them. Don't save. Okay, so let me share with you the screen to show you how it looks like to me from the vantage point of a student. There was an interesting thing that happened yesterday, and I think I also sent you a message concerning that for the STEM groups, and also the chemistry groups and all of the student groups who were supposed to meet yesterday. So if you did not make it yesterday to the meeting, which is fine, I was hoping that some of you will attend. I was there in the meeting at 1 o'clock. And also, it's really, you don't have to be involved within any of the STEM programs to be involved. Actually, there was so many interesting projects in there. One of them was by UCSD. They needed actually a decision yesterday to monitor the quality of the air in the region. And apparently our region does not have any monitoring stations. So they're trying to build one in there, or at least collect data temporarily until like February, and then I don't know what's going to happen after that. Probably they're going to have a more permanent station. They're also asking for other programs that involve, they think, UC Davis for another project involving a collection of also other data also. So they are trying to recruit students, and actually where you can get paid for it too, and do help grad students collect their data for their research projects. There was so many interesting stuff. We still have other things that might be coming in the future. One of them is, as I promised, but we don't know the date for it yet because it has been postponed by NASA, and that is the launch of the James Webb telescope. So it was initially planned for October 31st, but now it was pushed. So we don't know exactly, honestly, when it's going to be. I have had a chance actually to look at the James Webb, the actual James Webb, before it was shipped to the islands in, not the islands, what is that? Guyana, French Guyana, to be launched from there. And so we will know about that. So once we know the date, I'm hoping that we will watch it live and basically help celebrate it, leave the Earth so that it collects far more data, valuable data, including among other things, exoplanets and the potential of life on outside of the solar system. So that is one of the things that we might be doing in the future, and that will involve our classroom regardless, because if it's of interest to us as a class. And then there is also another stuff that is coming down the road that I'm hoping actually to, and that is involves also UCSD with some sort of, with some grants, including NASA grants and other things. So that is for yesterday at 1 p.m. and the window is still open. So I'm hoping that you guys will be excited enough to join some of these groups. And hopefully you'll learn a thing or two, and maybe you change career, maybe you change majors. Who knows? Maybe you like it enough to get involved permanently. Okay, so if you are not already, I'm not making any assumptions, so you may already be in that category. So, okay, so let me go back into where I was to share where we are, at least in terms of this week. We're in week 3. Again, this is typical stuff now that you've been seeing. The review from last week. Excuse me, give me a second. Let me blow my nose because I think it's a problem right now. 1 second, okay. Sorry about that. Anyway, so basically, this, I hope that you guys are seeing this now and following it. Here is the deal. I know some of you don't have the book yet, but I cannot emphasize on how important the reading is, okay? Testing is not based on this units. I know from the week 2 and week 1, we were doing 3 units at a time, and that's true, okay? And testing is not based on what is presented in here. This is a summary. These are PowerPoint summary to help you guide you basically in your reading. That's one thing. The other thing I also, guys, I hope that you have seen already that after the week is over, I come in and do a summary of the week, okay? Similar to what I do before the week starts. I go through this presentations briefly, and we discuss what I think are important points in there, okay? And then I come a week later, I'm in the beginning of the next week, to talk about what I think was important the week before. However, between what I think is important and what is presented in these units in here is not the entire story. This is just part of the story. The full story is actually going through the reading yourself. You have to have the book. I know that some of you are expecting it probably, or probably did not receive it yet, but you must have the book. And if you can borrow it, that would be great, because that is how you're going to be tested. You're not going to be tested on the summary that I am posting in here. You're not going to be tested on this PowerPoints. You're going to be tested on the actual units, the actual content in those units. The book does not call them chapters, calls them unit, divides the book into different parts, and each part is made up of several units. And I picked some units. You can clearly unit 7 and that is missing because it's actually included in here. So, or at least part of it in there, the concept is in there. So the point being in here is that you must do reading if you want to pass the class. And you must understand those things. If you don't have, if it's not clear to you, that is the time when you ask questions. That is the time when you discuss it among yourselves. If you can, maybe hopefully you can convince somebody it's this way, not that way, or somebody convince you the other way around. Shoot me an email, send me a message, and I will answer it. And we will move on. Just like, for example, the question. Okay, and Kova is helping in here with the book. That's great. So again, thank you very much, Kova. And we need to, that is where you're going to be tested. So this is item 1 of the discussion today. Item 1 today, you are tested not on these units. Can we turn off the microphone a little bit? Okay, that's better. Okay, very good. So item 1 of the day, I'm going to post it in here. And let me tell everyone that reading is not important, but I think it's crucial in order to pass the class. That's what I'm trying to say in here. And this, I would do it regardless, even if we are meeting in person and doing all kinds of demos and probably writing stuff on the board and doing things like that. It's still, that is how you're going to be tested. I still require reading in there. And the advantage of this book, actually, and I like it very much at this point, hopefully it does not change in the future. the units are small. It's about 5-6 pages at most. So the first 2 weeks, they were like very light, 15 pages or something, okay? This week is slightly more, it has 4 units, but it's still doable. I mean, that is something, the minimum level of reading that you're expected to do. So you really have to read those chapters, understand them, go through the examples in them. If you have any questions, you're supposed to communicate that to me. Only everybody else will benefit from it if it's interests everybody else. And that's how we're going to pass this class. Does everybody understand what the first discussion item is?
You mean what you were just talking about right now, or the first week?
Absolutely, yes.
I agree. I totally understand what you're talking about, except that I had a question on that, you know, the stellarium one, like right there off the week, the assignment that how you just wanted just to kind of like get to know it. I couldn't do it. I couldn't figure it out. I don't know what I'm doing wrong. So I'm going to try to remove around the more, and I'll just email you. But I just kind of went over it again today, and I still couldn't figure it out. So
how about if we do, for those who are struggling with it or have problems with it, we can do a session on it separate from these meetings.
Well, that'd be awesome, because literally, like, you know, I had reached out to somebody, and I realized I can't even do it. So that'd be awesome. Thank you, Professor.
No problem. How about Wednesday next week? And I'm going to send you exactly the link for anybody, and it's going to involve probably more people from different sections for just specifically for that activity. I know it's not a graded activity, just to get familiar with it. So can that would work. Please remind me that since you mentioned it, Kuva, it's going to be your responsibility now to send me a reminder by the end of the day tomorrow. If you don't receive an invitation for Wednesday, send me a reminder again, and I will send it to everybody. Does this sound like a good plan?
Yeah, that'd be great, because that way we can just get familiar, because that's what I was trying to do, and I went to it a couple times now. I'm like, oh no, I can't do it. So thank you. I'll remind you.
Okay, it's going to be an open. It's going to be an open session, and we don't leave that session until everybody is happy and satisfied that everything works for it, for him or her, and that's it. So that solves that issue, hopefully. Now, how about the discussion item today? That we have to read the content of those units entirely and understand them, because that is how we're going to be tested in this class when it comes to quizzes and exams. And that's the only way to pass this, to make sure that we're happy with it and understand everything. Sounds good. A lot of people are reacting on the chat, and that's good. Sounds good for the rest. Okay, so again, please remind me, Koba, of that tomorrow, okay, by the end of tomorrow. So I'll try to do it today, but I know I'm busy all the way to the evening because I have another meeting starting at 4:30 in the evening. So it's going to be a hectic day. Hopefully I don't forget, but if I do forget, please remind me, okay? Thank you. Okay, so I'm still sharing. I'm not sharing the screen. Let me share the screen again. Okay, so again, this is stuff that today's discussion items are going to be in here, okay? They're going to be exactly in this place in here that says live session discussion week 3 once the session is over, and then I post it back in the evening, hopefully, and then you will see it in here, okay? So this is item 1, and I hope that you guys are on top of it. Then we have the 4 units. Here are 2 stuff in here. I already sent you a message concerning one of the questions in here, okay? This is what we discussed last time, in a sense that what happened to my okay, good, it's still there. This is one of the things that is a homework assignment. A homework assignment is not an exam. It's not timed. You have all the time in the world to do it. You can look at the books. You can Google stuff. You can ask your classmates. You can ask your teammates. You can even ask me, okay? And I will not tell you, hey, you're supposed to find it in yourself. This is basically, I'll give you more and more insights until you figure it out. The purpose of this is so that you work your way through the materials and understand them. That is really the purpose of it. It's not a challenge. It's not a test of knowledge, in a sense. It's not like a quiz or an exam. Quiz is a short version of an exam that targets specific items, whereas an exam, it's usually more comprehensive. It covers more than one item. So this is really the difference between them. And I'm hoping that, as we discussed before, that you already are going to be working in teams of hopefully 3 to 4 at most, and working with your classmates. And again, working in online, preferably if you can. If you want to meet in person, you have to make sure that the health guidelines are all basically implemented, so that we don't have any other problems. But that is really the item in here that the point in here for the homework. So again, doesn't matter, the instruction tells you it's page 50 from the book, and there are only 2 assignments in there. So you look at them, you go through them, you discuss them, make sure you understand them, because that is how we're proceeding from this point on. So that is the homework assignment, and it has a due date. Somebody asked a question, because it's a direct question. I'm not going to reveal the name, but hopefully you guys understand that the unlimited time is not for the quizzes and the exams. It's only for homework. Does this answer your question? Okay, very good. So hopefully it's clear. Okay, for homework assignments, it's an unlimited time. For other types of homework, for assignments, no, like quizzes and exams, they have to be timed, and you cannot. There are different kinds of assessment methods. For a quiz, which has 11 questions, this one, no, 11 questions, it has 12 questions. I'm sorry, I probably do it on the 11th of September, actually. Okay, so this one has has half an hour time limit, and it's due the 11th of September by 11 p.m., just like all of the assignments. A quick thing as far as this quiz, this is timed, okay?
Why is it timed?
What? I'm sorry?
Why is it timed?
Because this is a quiz. You're supposed to go through those units from the first week, and once you understand them, then you should be able to answer this quiz. There are 12 questions, each question about 2.5 minutes. So that is basically, okay? You have 3 attempts in this one. If you don't get 100% to score in the first attempt, there is a time delay between the quiz, between the attempts. So you cannot take it immediately. You have to spend time basically going back through the units again and take it again. If you score higher in the second attempt, the first grade is dropped. So you're going to take the highest grade of all of the attempts. So again, you go through the quiz again. I must warn you, the questions change. So if you did the first attempt, do not expect to see the same questions again in the second. And if you do see them, they're probably going to be slightly different. So in a sense that, that's why it's really important that you go back into the first week's units and understand them, and make sure that you are in control of them, okay?
So you're saying as long as we just read it, go read it and just, make sure we take good notes, and just, they'll be okay. Because I'm just going to be honest, I don't care about putting it out there. I have overwhelming anxiety at times, especially when it comes to quizzes and when it's to timing, especially your class. I didn't realize how smart we have to be. And like, I'm smart, and I just took this class because I want to learn more about the world. I'm actually, I'm trying to be an alcohol and drug counselor. I'm going to be in behavior science. So I'm just like, oh my gosh, I'm starting to panic. Like, whoa, maybe I need to get a tutor for this class. And do you understand my concerns?
Can we do this? Okay, let me tell you this, okay? These are not supposed to be challenging questions, and I can actually sit down with anyone who needs help, basically making sure that to overcome these technical things and basically approach them with a much easier way than what they sound, because they are not really supposed to be challenging in a sense. All you're supposed to do is go through those things, understand them, and to the best of your abilities, answer those questions. Some of the type of questions are multiple choice questions. Some of them are actually multi-question answers. You check 1, 2, 3, and some of them are actually matching the ideas together. Basically, you match this with that and this with that. And granted that some of this, especially for those who are not have not had taken science before, it may be completely different and changed. How should I put it? New. So we have to approach that with a little bit of basically preparation, And once we have that, we should not have a problem with it. Let me tell you upfront the key concepts that you're going to be covering in this quiz. You have to understand the metric system, the meter for the distance, the kilogram for the mass, the second for the time. If the question asks you, is this, of course, there's another unit that we're not going to be using in here, but probably it's going to appear at some point, but not now, which is called the ampere for the current. Anyway, so these are the three, actually four, MKSA metric system. Questions ask you, is this a metric, is this unit in metric system? And you're looking for this combination only, meter, kilogram, second, maybe an ampere, but I don't think in this quiz there is an ampere, okay? Either one of this or a combination of this. It could be a meter times a second squared divided by a kilogram cubed. That's metric system. It could be a meter cubed divided by second squared. I don't know. I'm just putting up numbers in there. Okay, that is a metric system. But if there is something else other than this fundamental units, this is not a fundamental unit. Or if they don't have any of this, all three of them are missing. Okay, that is not a metric system. So those are some of the things that you're looking for in this type of questions in here. The other thing also that you need to be familiar with from the first three units are the following. The distance from the Earth to the Sun is called an astronomical unit, an AU, and it's about 150 million kilometers on average. Now, the distance on a larger scale than the solar system, and of course, this is important for studying of astronomy. So you cannot really go without this understanding what these units mean and their scale. The next unit you need to be familiar with is the light year. The light year, if you convert it to kilometers, it's about almost 10 billion kilometers. It's 9 times 10 to the power 9 kilometers. It's a big number, okay? We don't use it when we're talking about stellar distances, the distance between the stars. We use the light year instead, and even the distance between galaxies and so on and so forth. So because we cannot even use the astronomical unit because it becomes too big of a number too small of a number, so that the scales become too large for it. And we don't use a kilometer, obviously. We don't use even the meter, which is the actual fundamental unit of measurements is the meter, actually, but we don't use it in astronomy. We use the light year. And there is another unit that is actually there is another unit of measurement that we use that is covered in the first three units, and that is the parsec. And the parsec is slightly more than 3 light years. So it's actually bigger in distance than the light year. So parsec is 3.26 light years. So those are the things that when you read this, the first 3 units, you should be able to discover. So these are some of the concepts that you're going to be discovering in there. There are some questions in there. They're all related on the first 3 units. So again, if you're having difficulty taking this kind of exams, this kind of quizzes, please let me know. There are 3 attempts, by the way, not 2 attempts, 3 attempts for this quiz. And the system takes your highest grade, doesn't care how low you score. So you can do the first one just to get you into the mood of the test. You can just get in and just be familiar. It doesn't matter, okay? Just to see it, how it works, okay? Provided you come back at least for another attempt to take it more seriously, because otherwise you're going to have that grade, which is not good. So take the first one. It's just like when you're playing soccer, for example, or probably any sport. You first warm up, okay? To get you into the mood for it. See how it looks like. See the questions. Read the question. Try to answer it to your best ability. Read another question. Try to answer it. Now you know where the exam is geared toward, where the quiz actually is geared to. Go back into the quiz, into the units, and now you know the concepts that are covered in there. I just mentioned them. I just mentioned the fact the metric system and the units you used in there, and the planets also, the inner planets, the outer planets. Those are what we discovered in the first units, and how they are related and so on and so forth. So those are the things that you go. And then the next time around, the second time, you really have to be serious about it, because you have an idea and then you read, and now you should be ready for the second attempt. if things don't look great, does not, because you're not going to lose anything anyway. Okay, if let's say, for example, you scored 93% in that second quiz, but you would want to make it better. So at the end of the day, you take another third attempt at it. So that is how this works. Does this help a little?
Yes, that totally helps. And and thank you for, like, if I just have any questions, I know I can just reach out to you and I can, like,
Okay.
at least I go on campus, because I know I'm wondering, when you said, oh, as long as you have science, well, I'm going to let you know I can do math. Science and everything you said is not my greatest subject. So I'm going to embrace this challenge. Like, I'm really looking forward to it, and you're very helpful. So thank you for answering that, and I look forward to it.
No problem. How is everybody else doing? Okay, very good. Very good. Glad to hear that. Okay, very good. Okay, so this is the quiz. So don't panic. Okay, just proceed with it and hopefully you will have a ball. You will like it. Okay, so the units covered in here are these 4 units. Again, I'm going to do a brief introduction of these units. This is not in lieu of reading. You're supposed to do the reading. So let me talk about these units. And okay, so let me get unit 8 first going. And stop sharing. I don't know if I'm sharing that screen. Can you share? The answer to the question, there is a question directly to me. And again, I don't know if the person really meant it that way or meant it for everyone. But the question, the quiz is actually covering the first 3 units. Does that help? Okay, very good. Okay, so the first week, basically. Okay, so unit 8, again, is covering the lunar cycle. There is a project down the road that is going to really emphasize on this one, where you're actually going to go and monitor the moon on your own, okay? So this unit is very important to help you understand what you're going to be doing in that project. So I really hope that, by the way, that project is a required project, so you'll have to do that. And that is to go outside every night, not every night, at least the nights that are assigned. You go and you note the position on the moon, and you actually describe it and actually take a picture if you can. If not, then you draw it, okay? And you submit that as part of your assignment. So we have to get out and basically look at the sky, okay? So this one is the different phases of the moon. This is one of the things that fascinated us, and this periodic motion of the moon. And the moon goes through different phases, different ways, basically different shapes, from a full moon to basically nothing at all, to a quarter moon, to basically increasing in size or decreasing in size, and so on and so forth. So this is how we describe that motion, and you're going to go through these units. The month itself is actually, the word month itself is actually borrowed from the word moon itself, because it takes almost 30 days to go through that cycle, okay? One of the things that you're going to be understanding in here, at least covering in here, is the so-called sidereal motion of the moon versus that of the actual month of the moon. And the moon, like any of the other objects around the sun, because the moon goes around the Earth and the Earth goes around the sun, they change position with respect to the background stars, okay? And actually that is real motion, because it spins around its axis. That is what we're trying to discover. Okay, but in doing so, it shifts with the Earth that moves, and so its position with respect to the stars changes. So that's really how you distinguish that. And also the other thing also to discover in this unit is the eclipses. When the moon, I'm going to take this as the moon and this is the sun, and my eyes as the Earth. When the moon sits between the sun and the Earth, this is the sun and this is the moon, and my eyes are the Earth when I'm looking at things, then in this case we have a solar eclipse. When it's the other way around, when the Earth is actually between them, then we have a lunar eclipse. That's basically what that is, okay? Now, the question is, why do we have them sometimes and sometimes not? Because the Earth goes around the sun in the, this is the Earth, but I cannot do that now. So the Earth goes around the sun on a plane called the ecliptic, like all of the other planets. Okay? They go more or less on the same plane. And the moon goes around the Earth, not on the same plane, but rather on a tilted plane. Okay? Slightly tilted with respect to the ecliptic. When it's really, when the two planes meet, when the ecliptic plane and the plane where the moon goes around the Earth, they cross each other, that is when we're going to actually have the solar eclipse or the lunar eclipses. Otherwise, the projection will be off. I think there is a nice picture in here. Yeah. Here is what I'm talking about. The Earth goes around the moon on this plane, the blue line, okay? That is where the Earth is. The moon goes around the Earth on this white line, okay? When the two cross each other, then the shadows fall on the Earth or on the moon, depending on if we're looking at the solar eclipse or a lunar eclipse. The same thing is true here, okay? Now, when it's off, because the plane is tilted, when they don't cross each other, and now the moon is still between the Earth and the sun, but we don't see, in this case, a solar eclipse. The reason why we don't see it is because the shadow of the moon falls off of the Earth. It doesn't fall on the Earth, okay? Same thing, the shadow of the Earth does not fall on the moon, and same thing on the other side. So this is an important concept that you're going to be tested on, and you really have to have an understanding of what's going on in here about the lunar eclipses and so on and so forth, okay? Now, this is unit 8. I'm hoping that you guys will go through it and understand it. And what happened in here, and let me share again, unit 9. If I can find it. Share. Oh, man, I have to do it again. Share. Okay. Unit 9 is actually an extension of Unit 7. That's why I did not really include the Unit 7 with it. Unit 7 and 9 and 8 explain 7 beautifully. And that is basically the daily motion for Unit 7. That's why I didn't include it in here. It's not included. And Unit 9 deals with the calendar, actually, and the calendar and how it's really this repetitive motion of the moon, the Earth around the sun, and some of these planets. So we decided the following. We knew then about basically 5 planets plus 2 other objects, the sun and the moon. So we have the sun and the moon, that's 2 objects that go around the Earth. Of course, we didn't know that actually the Earth is one that goes around the sun, but we thought that, okay, the sun goes around the Earth. So we're gonna dedicate a day for that. We're gonna call it the day of the sun or Sunday. There is a day that is dedicated to the moon, and that is Monday, or the day of the moon. Okay, we knew about 5 other objects that go around the sun, around the Earth, I'm sorry. The other one is Mars. Mars goes around the Earth, so we dedicated a day for it, which is Tuesday. We know also Mercury, because Mercury usually follows the sun or precedes the sun, depending on what day of the is it evening or morning. That one is actually going to be the Wednesday, the day of Mercury. We dedicated the day for Jupiter, because we know also that it moves around the Earth and we can clearly see it. And that is the day of Thursday, actually. That's the day of Jupiter. And then we dedicated the day for Venus, which is Friday. That is actually the day for Venus, again, because it's similar actually to Mercury. It follows Mercury sometimes, which follows the sun, and vice versa. The morning star or the evening star, that's how it's used to be called. So the day of Venus, Friday. And then, of course, we know about Saturn also that does that too. So which is the day of Saturn, which is Saturday. So those are the days that we knew about. It's a good thing we didn't know then about Uranus and Neptune, because if you knew that Uranus and Neptune existed, that probably the week will be 9 days, not 7 days. Because if we knew about Uranus, the fact that it also has this periodic motion, and Neptune also, then we probably will have 9 days. Wouldn't that be fun? For we will have 9 days a week instead of 7.
I might have more time to do stuff.
Yeah, you will get to enjoy more work days during than now. Okay, anyway, we know about 7 days then, so we have 7 days a week. Okay, that's exactly how the days came in. But then we know also that the moon takes about 30 days to go around the sun. So we divided the year where the sun comes back to the same position to 12, because the sun does that in about 360 some odd days, and the moon takes rotation about 30 days, okay, 29.5 to be more specific. And then we have that basically a distinction between, actually the sun does not do 360 exactly, does not do 12 times 30, it does more, okay? So the calendar was off a little. So we have 12 months, and but the lunar calendar, which still is being used by a lot of cultures, including the Islamic culture, and we still have, because that's actually where the month is coming from, the motion. That's how we started counting things, is with the lunar motion, actually, counting 30 days a month and so on and so forth. So we came up with the Gregorian calendar, and that one has a problems also in it too, because the rotation of the Earth is not an exact number. So we have the leap year, where we fix that too every 4 years for February 29th instead of just 28 days in February. So that is how the idea of the calendar. The calendar actually was based on a how these objects revolve. I think actually it's the next unit, but let me find it, okay? Let me find where the next unit is, because I did not. Okay, so somebody's happy, just like, okay. So let me find the other 2 units, okay, otherwise. Okay.
So our calendar was made by the Gregorian calendar, and that's when we said that, and that was around the astrology. Even though there's 13 months, they only made 12. This is what I found it so interesting.
Actually, it's only 12 months. You mean probably the signs of the zodiac, which is different, but the 13, the 12 is actually very close to 12 months, much closer than any number, because 360 time divided by 30, that is 12. Okay, so it cannot be 13, it cannot be 11. So we have 12 months. It's just that 5 days sometimes that what we have to fix. That's what the Gregorian one. Okay, let me find first of all the other 2. Open them, because I did not have that open. And let me find the other one also. Because one of these 2, let me first of all put it. Stop sharing now. Was I sharing? I don't know if I was sharing or not. Let me share with you Unit 10, which is another one that you're supposed to be doing the reading for also. Unit 10 is a fascinating unit. I really encourage you to go through it in detail. And again, there will be a summary later on that hopefully you guys can enjoy. Look, in the ancient times, way before YouTube was invented and before Google was invented or anything else, okay, they knew the Earth was round. There are so many demonstrations for it. Let me pick up just 2 of them. Okay, one of them from the lunar eclipse. When you look at the lunar eclipse, because the interpretation was that the Earth is hiding the sun, and it's basically, I mean, the Earth is hiding the moon. I'm sorry, and we can see, if it's not a complete lunar eclipse, you can see the shadow of the Earth forming an arc. Okay, on the moon. Okay, and you can clearly see that that arc is moving. And it, depending on what time of the year, the Earth should be in different positions. So the Earth must be, first of all, at least a circular shape to produce that projection. Okay, so if you want to see an arc in here, you must have a circle. But during other times of the year, if it was really a circle and not a sphere, the projection would be just a line, okay? It cannot be a sphere. But anytime there is a lunar eclipse, it's always a spherical, circular shape, an arc, indicating that the Earth now is actually a sphere. That's how they concluded. Aristotle did. The Earth must be a sphere to do that effect. And everybody was convinced that the Earth is a sphere, not a flat surface, but rather a sphere. Okay? And then there was another phenomenon that you can clearly see. If you go in the ocean, and the old days they have boats, go to the ocean, to the sea, you can clearly see the horizon, the shore, start to drop as you move away from the shore. That means that the Earth is curved. No matter which land you approach, it's always going to appear from the horizon and start to rise. Whether you come from Greece to Egypt or vice versa, you leave the Earth that is falling behind for Greece, and you attend now the shores of Egypt that start to appear little by little in the horizon, indicating that the Earth is actually curved, whichever direction. If you happen to go to modern-day Lebanon, you're going to see also the same thing. And if you go to the eastern side of the sea, or the western side of the sea, which is where Italy is and all of that, you're going to see the same phenomenon, indicating that we are sitting on a curve, on a bowl, okay? Whichever way we go. So that is also another proof that the Earth is actually curved, okay? That the Earth is actually a sphere, not a flat surface. So there are some simple arguments that people have used then, and they were convinced with it before we invented YouTube and messed up everything for ourselves now. And some of us are convincing that this is not true, okay? Now, not only that, not only they thought it was a sphere, but they proved its radius and how much curvature there is in it. In modern day Egypt, in the city of Siam, which I think is Aswan, which is in southern Egypt, where there is a big with a big dam down right now. During the times of the year, the sun will be vertical. You look up during during noon, where the stick does not have a shadow. You put a stick on the ground, put it vertical, and it does not produce a shadow. So the sun is immediately above your head. On the same time of the year, the same time, if you are in modern day Alexandria, which was Alexandria then, you will all have a shadow for the same stick, for the same length. And you can measure how much shadow that is, and it's about 18 degrees. So you use simple geometry to show that the curvature of the arc of 18 degrees gives you an arc distance. Since you know how much distance between the two, they measure it in stadia, you can extrapolate to how big the entire circumference of the Earth is. And if you know the circumference, all you have to do is divide it by pi. To find the diameter, and to find the radius, divide that number by 2, and you already have the radius of the Earth, and they had it almost accurately. So not only they know that the Earth is spherical, but they were able to measure its radius. And by observing the lunar eclipses and projecting how many Earths basically are projected on the moon and vice versa, you can tell the size of the radius of the moon versus the radius of the Earth, and it's about a third, which is exactly what we know today. So they were not only able to determine the size of the Earth as a sphere, but also to determine the size of the moon also based on this lunar eclipses. Now, combine that with another observation for the here is what I'm trying to say in here. Take a coin, doesn't matter, this one, for example, okay? And I would want to determine how far an object is. If I know its size, let's say the moon, I can bring the coin close to my eye and it blocks everything from my view, okay? If I move this coin, it starts to, things around it starts to appear little by little, little by little. So if I do this for the moon, okay? if I do this for the moon, and as I bring it closer, of course, right now I'm blocking the whole view just with a quarter. And as I bring it out, now you can see more and more of what's going on. If I do it just for the moon, the object behind it, at some point, the moon starts to appear behind it, and other times it does not. Okay, clearly seen here. So if this were the moon, okay, so if I bring it closer to you, now you don't see anything. But if I bring it just enough so that it starts to appear, then I use simple geometry for the angle tangent, since I know the size of the moon, and since I know the size of the coin I'm using. At that time, they did not have nickels or dimes or anything like they have other coins. I can actually tell how far the object is using simple geometry. So they know how big the Earth is, and it's a spherical. They know how big the moon is, and it was using basically lunar eclipses. And then using this simple geometrical trick, he can find how far the moon is, 380,000 kilometers from us. When the moon is quarter moon, and you look at it, so this is a quarter moon. So the assumption is the sun is shining from here, so that part of it is hid and part of it is shining. And you look at it, you can make an assumption that that's a right angle triangle. Since you know one side of the triangle, and if you can measure the angle, which you can, then you can find how far the sun is. It's amazing. This is before the advent of all of the telescopes and all of the Googling stuff and phones and things like that. They were able to do all of these calculations a long time ago, before even Mr. Newton was born. This is thousands of years ago. So I'm hoping that you guys read this chapter, or at least this unit, and enjoy the reading in there and see how much basically clever those people were, using simple geometry. Using simple geometry, trig functions. They were able to determine all of these measurements, all of these things. But today, we're struggling to convince some of us that the Earth is not flat, the Earth is circular. Okay, because most of us basically, or at least that's these people, they are sitting in their living room, they have no idea the entire world, as far as they're concerned, is their living room. And they're making all kinds of nonsense assertions. They don't go outside like those people were, and to look at things, and they will see them clearly as day and night, basically what's going on. But this is actually what's going on. The Earth is round, and the Earth is, this is how big it is, because they were able to measure how much the distance between the two cities in Egypt were. They didn't use meters at that time, they used the stadii. How many stadiums basically lined up because they had a lot of stadiums in there. You read a little about Greek culture and the Roman cultures, they used that a lot. So that's the unit they used, but they came up very close from what we know today. So using modern techniques. Okay. I hope you will enjoy this one in here, because it gives you some powerful things to basically learn about the numbers, because the numbers tell a lot. Okay, let me share the last unit. I know this week is a little bit heavy in terms of units, and 4 units, and it's not really a lot in terms of reading. 20 pages is not a lot. Hopefully you should not have any problems with that. Okay. And this one is actually another one that is actually coming down the road, another project that you will have the option to do or do another one. In other words, this is one of the required choices. So you can choose this one or another one, depending on which one you like. This is about basically the motion, because when you look at the stars, there are 2 kinds of stars, the stars that stay fixed in the sky, and then there are those stars that change positions week in, week out. And those are the wandering stars, or the wanderers, and they're the planets, what we call today planets, because we're sitting on the Earth and we think everything revolves around the Earth. Except that some of them, especially Mars, had this weird motion. Sometimes it appears moving back from everybody is going from east to west, including Mars for a lot of times. But sometimes it appears to be going from west to east in the sky. So the explanation for it by Ptolemy was that, look, it's going in a circle because the argument is based on heavens, and that heavens are perfect, and the only reason why Earth is not perfect is because we sinned in Earth, and that's why it's not perfect. Since heavens are perfect, and the only perfect shape there is out there is a circle. So the planets are going in a circle around the Earth like all of the other objects. And Mars happened to be doing something weird. According to him, it's going to go in a circle around this big circle. Then when it's going in the same direction or its own circle, then it's going like everybody else from east to west. When it's going in its circle in the other cycle, when it's in this position, then it must be going from west to east. And that could explain the retrograde motion of Mars, because you can project it and you can see that it really appears to be moving backward. That model, of course, had some errors in it, and later on, actually, Venus was also discovered to do the same thing. And so Copernicus, who was asked for something completely different, he was asked to fix the calendar because the calendar was off. Easter was not happening when it's supposed to be happening. Christmas was not happening and it was happening sometime in the spring. So we need to fix the calendar, they asked them. And the calendar was based on this model, the model where the Earth is the center of the solar system, and it's called the geocentric model. So when Mr. Copernicus looked at this data and looked at trying to fix the calendar, he said that there is something off. And the thing that is off, according to his judgment, is the fact that the Earth is not the center of the solar system, but rather the sun is. Then he had to explain the retrograde motion of Mars. He said, okay, well, they're sitting on circles still. And that's his mistake, actually, because he didn't have any other data to back him up. But he made the assumption, again, based on the fact that sin has messed up Earth, and that's why we on Earth are, it's not perfect things, but the heavens are circular, which is the best shape possible. So he said that they're different circles. Okay, the celestial sphere is made up of like shells of the onion, basically. Each shell has a different objects in it. So the Earth is here, and Mars is here. Because the Earth is closer to the sun, it must move faster than Mars. And if you project a line in here from the Earth, when you are looking at the Mars straight out versus the background stars, it appears in this position. Later on, as the Earth is overtaking and it's moving faster, Mars, it appears in this position, moving east to west like everybody else. But later on, when you are in this position, because the Earth is overtaking Mars, then it appears that Mars has moved backward against their background stars, moving west to east. And if you continue with this projection, you're going to be east to west until basically the Earth is going to come into the other cycle, the other side of the cycle, in which case Mars starts to resume its normal east-west motion. So that can explain the retrograde motion of Mars. And that was able to, basically based on this analysis, we have this geometry now because of this different layers of onions structure and the fact that everything is going around the sun. Well, we have different positions when an object, a planet, for example, Mars or Jupiter, is on the other side of the Earth than the sun. Then this is called the opposition. When that same object is actually on the other side, where the sun is between us, or it's on the other side of the Earth, that's a conjunction. Of course, we will have the superior conjunction where it's for the interior planets, of course, planets inside. When it's on the other side of the sun, or we have the inferior conjunction when it's actually between us, exactly straight out. These two positions are called the quadratures. And from there, using simple geometry, simple basically mathematics, he was able to determine how far these objects need to be if I assume that this is one astronomical unit. Remember, the Greeks already calculated that distance. Okay, we know that distance, it's about 150 million kilometers. So now he had to find the distance, for example, for Venus or Mercury using this geometry. If I know this distance, how much the others are, using trig functions and using the time it takes for this ones in here, the angles basically takes to do this. So this entire angle, And also now I need to include other planets, Mars, of course, Jupiter, and Uranus. So let's look at his calculations and see how good his calculations were. Today we know that the Mercury is 0.39 astronomical units from the sun. This is how much he found it, 0.38. It's amazingly close. Okay. For Venus, exact match. This is a starting point. This is basically what we're assuming the number needs to be. So this is, we're comparing it to how far things are versus how the Earth is from the sun. Mars, amazingly accurate. I mean, exactly. Jupiter, extraordinarily close to the correct number. And Saturn was slightly off, but not by much. Okay. All of this were done before Galileo, before Mr. Kepler discovered his laws, where these numbers can be even improved a lot better, which is going to be the next few units, Kepler's laws. Okay. So we are really embarking now on the real astronomy and how things are done, how things are basically discovered. You'll be convinced when you look at things later on in the sky, or you read an article later on in a magazine, or you watch a TV show talking about the planets and the stars, that these required a lot of work, a lot of observations, and the amount of confidence you'll come up with that this is true. Okay. At least this is the best explanation that we can come up with. There is no other scenario for it. The Earth is not a flat, flat surface, because if this is the amount of stuff that is out there. Okay. Any questions?
No, thank you. No.
Yeah, the only item today is the item I mentioned earlier about the fact that we have to read these things. Okay, that is how we're tested. Okay, we have to read them. Hopefully you will immerse yourself in those readings and enjoy them. If you have any difficulties, please let me know. I know the purpose of these presentations that I do in here actually to entice you to read them and to look for this basically landmarks that I'm setting for you guys. Comes next week when I post Unit 4. You will actually see a little bit of review of these things, and hopefully you will have discovered these things and actually went through that. So that's basically how we're doing this. In addition to the activities I propose to you guys, to basically have those things fully basically covered and things like that. Okay, I promised something, and I know I signed one of the guys. I put a task for her to take care of, but all of you are actually responsible. If you don't receive a message from me, hopefully by this evening, tomorrow morning, send me a message saying you did not send us that that invitation for Wednesday for an open session.
Okay, and I have a question.
Yes.
Since I'll ask it. So for the discussion for us to put is what you're wanting us to put in there is to make sure that we read the units or we won't pass or we won't do the quizzes. That's what you're asking us to put in this discussion.
I didn't say you will not pass. I will say you will have difficulty. Okay.
Okay. Well, that's a note to my personal self. You know, I strive for excellence. It's not perfection now. So, okay. So that's what I put. So, but that's what you'd like us to put in the discussion part.
Yes. Reading is a required component of this class. And no matter which class I teach, no matter where I'm teaching, including some of the basically calc-based physics classes where people are discovering relativity and other concepts, it's still a must, because we don't read, we're not going to basically uncover all of the ins and outs of these things. Sounds good?
Great, understood. Thank you.
Thank you, guys. So I'll stop the recording.